Right. Morning, everyone. Okay, so for today, I will be conducting a revision for the first half of this module. All right, just my half. So regarding the exam for this half, there'll be a total, or rather, for the exam for this module, there'll be a total of 4 questions, and for my half, there'll be 2 questions. Right. So Prof. Liming will set another 2. So each question will be 25%, and the whole paper will have a 100% score. But in terms of weightage, it will be 30%, right? In terms of module weightage, it will be 30%. Okay, so the exam may be online. If we look at the COVID figures currently, is likely to be online. If it is online, registrar will remove this 10%, this reading time. I'm not sure why. In fact, I only found out last trimester when I was teaching the DCO group. I actually gave 10 minutes and they told me to remove it. So if it's online, this 10 minutes will be removed. So it can be a closed book. So far for my half, it will be likely to be closed book, which means there's a lockdown browser, the usual stuff, right? As far as my half is concerned, there's only a need to study and understand the lecture materials, the class materials, both lecture and the lab, right? Both lecture and lab, not just the lecture. And you might want to have with you a non-graphical calculator because you may need to do some calculations. For example, conversion of bases from base 16 to base 10 and vice versa. Okay. So these are the topics I've covered in the first half. Second half, I will leave the revision to Prof. Lu. Now, what I want to say is, even though there are 2 questions, each question has several parts. So do not try to spot, because academic policy requires us to distribute the focus of the questions. So everything that is taught will appear in one of the questions. It will not be a whole question. For example, let's say question 1, you have A, B, C, D, E, right? So A may be here, B may be here, and so forth. It will be distributed out, separated out. So don't try to spot. Just look through with understanding. Try to understand the best that you can. So for lecture 1, basically we covered, for most of the material will be on the different malware types, right? So you should be able to distinguish between a virus and a worm, for example, or even a Trojan, right? How one depends on the host, the other does not depend on the host, right? And then we also look a bit at the malware evasion mechanisms, polymorphism, metamorphism, and so forth. The malware zoo is more like an abstraction of the workflow, which represents the 4 different stages of the malware analysis process, and is supported by automation. And the reason or justification for the malware zoo is because of the volume of new malware that we encounter on a daily basis, right? So the automation helps us to deal with that volume. For lecture 2 is basically on basic static, the different techniques and tools we can use to extract out the intel, looking at strings, for example, looking at metadata in the file header, how to check whether it's for whether the sample is packed, unpacked, or partially packed. All right. Okay. So since I'm here, I will just mention in passing. Although most of you got it right for quiz 1, there are a few, I think 2 or 3 people who were confused. I think they got it in the reverse order for between packed and unpacked. Now, also, in order to check whether it's partially packed or not, you can't just check one. If you're using PE view, for example, right? The malware has 4 different sections. You can't just check 1 or 2 sections and you find that it's unpacked because the raw size is bigger than the virtual size. You have to check all because some of the samples we have seen can have 3 of those 4 sections unpacked and 1 section packed, in which case it's partially packed. So to determine whether it's partially packed or not, you have to determine, you have to look through all 4 sections, okay? And then we talked about host-based and network IOCs, and we saw some examples. And also in your practicum, you also got to extract some examples. Now, here again, I want to say something. Unless a particular file service is, and then we talk suspicious about host in a sense, let's say is misnamed, all right? So one of the letters is replaced by something else. For example, a DLL, a system library, one of the, I think it was kernel 1 instead of kernel 32, then you know for sure that is unusual and is an IOC. But in the case where everything is fine, the service has the same name, create file, for example, or URL download to file, these are system services, right? A kernel 32 without a typo is a system DLL. System artifacts cannot be treated as a host-based or network IOC, all right? So be aware of that. IOCs are, as the name implies, they are indicators of compromise. So they indicate that a compromise has occurred by a certain malware sample, right? And because of that, they need to be different from those system artifacts that we encounter. Otherwise, if you code a system artifact as an IOC, then every single system that has those system artifacts is, by your definition, is considered as compromised. It doesn't make any sense, right? Okay, so lecture 3 is, in fact, lecture 3, lecture 4 is on reversal of the malware. So this one, you have to know, you have to gain a working knowledge of your assembly language. I know that some of you are maybe a bit apprehensive over the use of assembly language, but unfortunately it's one of the topics. And as I said earlier, academic policy does not allow us to limit the coverage to only certain topics. It's most unfortunate. We have to cover the topics. So in this case, your focus is not so much to write, but to be able to read a piece of code, short code, not more than 15 lines, right? And understand what is going on in that code. So that, for example, if you're asked to patch the code, you know where to patch it to stop a certain jump function, for example, to prevent a certain call to a certain function from happening, okay? Or you could be asked to patch it to reduce it to a shorter equivalent. Maybe that original assembly language segment is some garbage code put in for metamorphism purposes, right? Just to fool the analyst. So that piece of code can actually, maybe originally is say 12 lines, 13 lines. It can be actually reduced down to maybe just one line. So in order to reduce that code, to know what to reduce it to, okay, you must understand the original code, what it was trying to do, together with the redundancies, before you can replace it, okay? And then for the second part of the reversal, we talked on the stack frame, right? And how the stack frame is set up and torn down. And you saw the two different sections, the prologue and the epilogue. And there were some slight differences among the three different call conventions, right? So that is something you should understand and be able to distinguish, okay? The second part of this second half will be on the mapping of the assembly code segments to the C constructs, the high-level code constructs, right? If there's a if-else, if there's a nested if-else, switch construct, loop constructs, what do they look like? That kind of thing, right? And then we also talk about entry point and exit point obfuscation. You probably have also encountered this in your quiz. And based on the quiz performance, I think most of you understood this part, so there's really nothing much to talk about. Last part will be on the dynamic analysis, both basic and advanced. Okay, so now week 9, that means after the 1 week break, that's week 6 next week. Then after that will be week 7. Week 7, you will be doing a basic dynamic analysis lab exercise. Now in week, sorry, I think I got the weeks wrong. This is week 6. Next week, the term break is week 7. Week 8, you'll be doing a lab exercise on basic dynamic analysis. Week 9, you'll be doing a quiz. So what I'm trying to illustrate here is that basic dynamic analysis, if you're using the Windows as the client and the Kali as not Kali, Ramnux as this server, the setup is pretty standard. So by the time you complete your lab exercise in week 8, you should be quite familiar with the different steps. The thing is, being familiar and writing it down are two different things, right? People can have it familiar, but when they write it down, it tends to be a haphazard mess. So my recommendation is to keep a systematic log of how you set up the environment in your mind. So when you're called to write it up, you can do so in a systematic way, okay? Now for the advanced dynamic analysis for debugging, so we have a source level debugger, those used in the IDEs, which we are not so interested in, and those at the assembly level. So at the assembly level, we illustrated the advanced dynamic analysis with Oli debug, and you saw the difference between single stepping, the two single stepping techniques, step into, step over. And you know that step into means you have to go into each step each instruction of a function. Step over means you treat the functional call as a single step. There are both advantages and disadvantages, as you know by now. When you step into, you get to examine the functional call in the call function in detail. You step over, it saves some time. So it's used more for familiar functions, right? Of course, there are trade-offs. Again, it's a judgment call. If you step over a function, let's say a printf, if it's truly a printf, it's fine. If it's a hijacked printf, then you are in trouble because that hijacked printf, and you just step over it, once it finishes calling, when it returns, it could return you to some obscure memory address, and you don't know what happened, resulting in either the analyst exiting from the program or an exception will be thrown or you're stuck somewhere. All right, so those are the trade-offs. And of course, in any debugger, you have the capacity to set breakpoints, and breakpoints should be set judiciously so that they can study certain malicious action safely. So it's normally set just before the malicious action takes place, right? And setting the breakpoint also allows the patching of the assembly code either to comment out that malicious function call, or to, if you want to study the malicious action in detail, you can change the order of execution by passing in a patched parameter that's different from the actual executed one, right? Okay, so onwards, there are some past year exam questions and recommended solutions. Now, before I go through, I just want to say that this past year questions in the earlier years, you will, although I did say I will only show the first half, in the earlier years, you will see parts of the second half coming in, questions on virtualization, for example. And the reason is because in the earlier years, there were only very few of us. So I was the only one teaching both halves. And that's why in the earlier years, you can see questions from the second half also appearing, right? But don't worry too much about it. Basically, look more at the questions in the first half, for my part, to get an answer, some exposure to how and what questions are set. Okay. Now I can't record and I can't upload the questions because, again, these are academic policy restrictions, right? If you're not happy, you can go and speak to the registrar's office. There's nothing I can do. So, okay. So before I go through the questions, are there any questions from you? Now I have to. What was I going to say? No. Just to let you know, the D1 material has been released on the download server, and so you can download it and start. So your submission is after the 1 week break on the 25th of October, which is a Monday 6 p.m. evening. Okay, so it's a team-based project for this D1. Okay, yes. The other one is the quiz one. Quiz one, I finished marking. Now I will need to enter the marks into the system so that y'all can see what you get. All right. Now, at the same time, because of this online thing, if it's face to face, it'll be easy. I can give you a one-to-one feedback. Now, I know I contemplated using Zoom or Teams earlier to do the feedback, but it's going to be very it's going to take a long time, right? Setting up one link after another. Now, so what I'll do instead is I will type out an overview of the performance in the paper. That means I will address those common issues that occur in a number of different papers submitted, and I will upload this, and then you can take a look at it to see, compared to what you have done. So I think that way will be easier. Yeah? The coverage is more. And if you have further questions, you can always come back to me if you want to have a one-to-one. After that, sure, then we can then zoom down. Okay. Okay, so just to continue, like I said, I'm not supposed to upload these questions. So this one is what is a malware zoo? Draw a flow chart showing the missing steps. Part C is what approach will you use to check that the sample is packed or unpacked. So this is the suggested solution. So you can have an assembly language segment like this, and you're asked to explain what the code does and how malware can make use of this code segment. Okay. So the suggested answer. This is not the only NTBM code segment. There are others, all right? So in the second half, you will be exposed to different types of segments other than this one.
Prof.
Yeah.
You're not sharing your screen.
Oh, I'm not sharing my screen.
This whole time,
sorry.
yes.
I'm so sorry. Let me start again. I am so sorry. Let me start again. So I don't have to start from the front, right? Can I start from the questions? Okay, never mind. I just start from the front. Okay. So I was talking about the exam, all right? Online, if it's most likely, it will be most likely online, so there'll be a lockdown browser and stuff like that. So far for my half is likely to be closed book, but again for my half, whether closed book, open book, I don't think it will make a difference. Okay. Topics I will cover in my half will be all this that I've taught in the first half, and then I went through all these subtopics in the different lectures. Okay. All this I already uploaded. So this is from here onwards will be samples of questions, past year exam questions. And I was saying for the first few years, although I'm now covering the first half, there will be questions that focus on the second half. All right. So what I'm saying is questions like this one, list tree virtualization approaches. And that's because, as I said earlier, in the earlier years, there were very few people. So all those who are teaching modules have to take over the whole module. All right. So in the earlier years, I had to cover both half. So this is on the, but this, not to worry, because this will be taught in the second half as well. And there will be a separate revision for questions like this, okay? But as you can see, the test is on what you have been taught and what has been covered in both the lecture materials and the labs. So one thing is, if it is an online, there'll be definitely less of this kind of drawing and labeling things, because the online medium doesn't really support drawing very well. So it'll be mostly text answering. Should there be a part that requires you to draw, for example, let's say in the second half, then one way some people get around it is that they draw it on a piece of paper, they take a picture, and then they transfer the picture and submit the picture, okay? But I will avoid for the first half, for my part, to solve that problem. So these are the other questions. And this is on the companion virus. Another assembly language segment. Now, since you are here, just want to say something. A no op by itself may indicate garbage code insertion. It may not. All right, because if you look back at the lecture slides, you will see that the no op has several purposes, and one of which, besides garbage code insertion, besides that, is to achieve word boundary alignment. Remember, it's a fetch, decode, execute. When you fetch, you are fetching in double words, 32 bits one time or 4 bytes. So some instructions are an odd number of bytes. So you add in a no op to align it to the next word boundary so that it can be fetched in a 32-bit block. All right, so it doesn't mean that with no op, it is a garbage code insertion. All right. And if you use the CFF, for example, yes, a number of you have spotted that there's a quick disassembler there, and you can look at it. In a way, you're partially right, but such manual analysis can only be limited to very simple obfuscated code, right? For example, you are using a couple of these, for example, you guys say, oh, we see a number of these here, so likelihood there is some attempt to change the code signatures at this point. That's possible. But if you look properly at the quick disassembler, it lacks the comprehensive analysis functions that you find in IDA Pro. You cannot jump from one point to another. There's no cross-referencing and so forth. So if you try to analyze the garbage code in general, the garbage code need not make use of no op. It can be a series of redundant instructions, like what we showed just now, which can be reduced to just one or two instructions actually. Now, in that case, it's going to be very difficult and very challenging for you to use that quick disassembler to analyze, all right? And having said that, the main function of the CFF is actually more to show and to review whether there is any packing. By itself, unless you use it manually, there's no automatic detection of garbage code. And right now, the number of tools that can do it is also very rare. Is because how the basic question is, how are you going to distinguish garbage code from normal code? You can't. Garbage code are also a mixture of instructions, just that it's been written so that there's a lot of redundancy, a lot of useless steps. So how do you actually define useless if you don't run it? The only way is if you go through it visually and you spot it. Otherwise, it's very difficult to distinguish, right, between such useless normal code and a really normal one that's coded by the programmer. Okay. So as I said, this kind of evasive code, VM, you will see more of it in the second half. There are some which are not only anti-VM, they are anti-debug as well. Okay, so reference to different data structures to detect the statuses and so forth. Okay, so this is a decryption loop. So you asked to explain it. Yeah, there's something else I want to mention. What was it I want to say? Yeah, try to recall what I wanted to say. Oh yes, now I remember. Some of you mentioned to use timeout. That means you go to sleep, you wake up again to avoid being detected. And you are not wrong, but sleeping or the use of a timed facility is very much specific to the analysis environment you're talking about. If we're talking about an automated sandbox, you set up tools and so forth, that every time a payload or file goes in, it takes the file, it will run it through a series of staged analysis. Yes, then in that case, the use of timing is, I would say, is quite effective. If you use the right primitive call, because the automated analysis sandbox does not span forever on a single payload. It only spends between 10 to 15 minutes. If it can't find anything, it pushes it on. So it makes sense in that case to use a timeout or some kind of timing or idling mechanism, or even a series of loops, for example, to just do some useless thing. Then it makes sense. But if you look at a simple traditional antivirus scanner, it's not going to work. Why? Because the AVS is really dumb in the sense that it doesn't have all those different features, different stages, but the strength it has is as long as the endpoint is powered up, it continues to run, right? So anything that comes in, a file, for example, it will hook onto it and it will monitor and it will keep on monitoring it. So you can go to sleep it will not back off. You wake up again, you will start analyzing. So the timeout is not going to work on such ABS solutions. Okay, so you have to be careful where you use timeout. You're not wrong, but you can't use timeout everywhere in every single context. You can't. Okay. Okay, so these are the different call conventions. So like I say, uh, it will be expedient to go through the different call conventions and recognize the subtle differences between the prologue and the epilogues. Okay, so there are three, right? CDAC, standard call, fast call. Okay, maybe I should stop here for a while just in case there are questions. Any questions? Yeah, I'll just continue. If you have any question, just unmute yourself and ask, because I won't be returning to this screen to check on the chat. So, okay, continuing with the questions. So this is on the standard call. This is on the Shifu banking Trojan, the payload. Basic and advanced dynamic analysis. This one is on checking the locale and the different malicious functions that are called depending on the locale value. So as I said, after you've gone through enough times of setting up the basic dynamic analysis environment, you more or less have this in your mind. Yeah, so if you want to, let's say, teach someone how to do it, you must be able to express this in a systematic way, step by step. Yeah, and I don't think it's the knowledge is the problem, but then it will become a matter of communicating it in an organized fashion to make it clear, right? So this is one example, assembly language code segment reduced to a single equivalent instruction. Okay. Okay, so that's all I have. Any questions? Okay, so if you're talking of examples, yes. For example, to give an example of a worm, those kind of things, yeah, you only need to know those that are indicated in the slides. So I don't know whether you have gone through online exams before. Online exam, the proctoring is even tighter because you see, in a physical space, you have a physical room, right? Physical exam, you have a physical room. In each room, there are probably two proctors and one from admin. In the online one, the registrar, the admin, the academic admin, and the faculty are all linked in the same room, so-called virtual room. So any question that you want to ask regarding, for example, interpretation of an exam question, if I answer like that can a lot, those kind of things, you will straight away be clamped down. No one can answer you, so don't ask those questions. Yes, you have lab today. Because it's week 6, you still have lab. So as I said, your D1 is already uploaded this morning by Paul. So you can, regarding last week's lab, you can email me because it's a virtual lab. So yeah. Another query from me, when reading, will there be insert question asking what's the value of, no, this kind won't be, but there might be a question asking you what value is in the register EAX, for example, or EBX, that kind of thing, yeah.
Hi, Prof.
Yep.
Like, taking example from last week lab, right? Like you just now say about the sleep timing. We need to like convert like milliseconds to like whatever whatever units you all want.
Yeah, so if the question asks you, for example, how long, if it's just how long will the sample be sleeping, then you can express it in minutes, seconds, doesn't matter. But if it says how many seconds will the sample be sleeping before this happens, then you have to answer in seconds.
Okay.
Yeah.
Thanks, Prof.
Right. And as I say, bring a non-graphical calculator for the exam. You don't need a graphical one. There are no graphs to plot, but you might need to do basic calculations. By basic, I don't mean just plus and minus. I'm talking about those code conversions because addresses are normally in hex, right? When you calculate something or when you do a logical operation on them, and then what is left behind is in a different base, not decimal. So you will want to find the value inside. Maybe for the next instruction to operate on, you need to calculate, right? So bring the calculator for that purpose to do calculation.
Prof, to add on to what you just said, is it similar to the sleep example that in the previous lab?
Not, yeah, in a way, yes. In a way, yes. If your sleep values are originally hex codes, right? And then you need to convert it to some integer number of minutes, which is decimal. Yes, you have to use that. So that's one good example, yes. But I was also referring to other examples. Sometimes in a code segment that are, you move something to here, load effective address or something into there, that kind of thing, then there might be an expression there which makes use of the contents of one or more registers, which previous instructions, something in hex is loaded inside, but the expression is a decimal calculation, and the result need to be in decimal for some reason or other. Those are other examples where you need to do conversion.
Then, Prof, will we be required to know all the common assembly language?
You need to know the common ones. Yeah, you need to know.
Test, that kind of.
Yeah.
Okay.
So certain things you have to bear in mind that if you have done 1003, the source and destination order, the operand order is now reversed, right? That's one. Two, you must distinguish the difference between, for example, a register that's specified just as, for example, EAX, and a register specified EAX with the two square braces. So you have to remember the difference. Right? One is just get the value inside the register, use it for whatever purpose in the instruction. The other one is use the value inside the register, use it as an address location. Go to that address location, take out the value there. Right? I'm talking about the second one is the one with the square brace. So that one you have to be careful because you know instructions, you get the previous one incorrect. It's like any other programming language. The rest of the instructions will use the wrong value. Okay, last call. Any questions? If not, I will end this. Okay, so later on, lab is online. If you have further questions, please email because it's been now converted to online mode. Good and bad lah. Bad if you have detailed feedback. Other questions is difficult to speak. But nevertheless, as I said, I'll be consolidating the feedback across the cohort for quiz 1, and I'll upload that. Okay, so you can take and see which part is relevant to you. Okay.
Sorry.
Yeah. Sorry. Yeah. Go ahead.
Cut you off. So this lab will not be able to like Zoom consult you. Is it only can by through email?
Okay, you can also Zoom but when you Zoom, do have more than just one question. I will prefer a collection of questions because otherwise, you Zoom one question, then you go, you Zoom again. It's not going to be very optimal. Yeah, that's why I thought that, as I say, it's just a suggestion. Email is better because it doesn't have a constraint, right, of a certain time. Because for Zoom, not only that, I could be having another meeting elsewhere, another Zoom session elsewhere, and then I have to synchronize. Email, I don't have to. Whenever I'm free, I just answer. So it's a matter of, I'm just trying to, it's also good for you because you get more of your things packed together and answer at one time as well. So it's more of efficiency rather than anything else.
Okay. Prof,
yeah.
Now nothing else. Can I ask using this session like regarding last week lab the number 15 question 15 it asked for the in instruction, but I tried to use the searching but I cannot find the in instruction. Even I try to find the hex, I also cannot find.
You mean you cannot find it in the assembly code?
Yes.
Oh,
I
that's
believe
strange.
should be have, but because based on the question being asked, so but then using the search function I cannot find it, so I don't know whether I'm doing it correctly. Is it possible for you to show us how to actually find?
Okay, let me go through that again because I also don't know which part you're talking about now. Also got to go through again. Let me try it first, and then I will explain to you.
Okay.
Yeah.
Thanks, Prof.
Because right now I got to go and dig it up. Yeah, and then my sample is on the hard disk. It's not on this laptop, so I got to plug in, and it will take some time. So you're saying what you can't? Your concern is question 15, is it 15? Is it?
Yes. The in VMX, the VM1, the VMXH.
VMXH. Okay. Okay. I take a look.
Thanks, Prof.
Yeah. Any others? Okay. If not, then I will. We will meet or not during the lab. Okay. Right. See you. Bye.
Hi, Prof.
Is Kai-Wen here? Yong Kai-Wen?
Yes, Prof.
He's here.
Yeah.
So nobody's looking at my screen. He's here. You
Yeah.
just use the G as in the instruction manual. You go to this location. You can see the in is already there. And all the different VMX strings are all here in hex, exactly as stated in the lectures.
Oh, so it's not directly some global variable put inside it.
Let me just show you the VM itself. Where's my VM? Okay. It's here. There. So the instructions are already indicated in the solution that I uploaded for Lab 4. So you just use the function G and then you just type in the address and you click OK, it goes straight to this point.
Okay.
Okay, right. So any other question, just let me know. Yeah. Okay, bye.